All right. The electricity cost has gone up since I first did this question. So here's our plan. There's a couple steps here. So step one, let's use that resistance to find the power in watts. And then we will find the energy by multiplying by time. And the electricity company charges by kilowatt hours. Kilowatts times hours. That is, you can tell it's an energy unit because it is power times time. Kilowatts is power, hours is time. So we'll transfer from power to energy in the unit of kilowatt hours, and then from that we'll figure out the cost. All right, here we go. There's about 3 different equations for power depending on how you arrange the variables. One of them, the appropriate one here, would be not IV, because we don't know the current specifically, but V squared over R. You get this one from taking IV and inserting V over R for I. We're plugging in household voltage of 120, and the resistance was given. Wow, lo and behold, that gives us exactly 1,000 watts. And that is our power. Let's first convert that to kilowatts. I move the decimal point 3 places and multiply by the number of hours in a month. A month is about 30 days. Let's convert days to hours. So we're taking the kilowatts, multiplying by the number of hours that we run the heater. That gives us kilowatt hours. Now, I don't know about you guys, but I think we're paying upwards of 12 cents per kilowatt hour. So we just need to multiply that amount of energy times the cost per kilowatt hour. Oh, and while I'm at it, let's cancel days up here. And we get $86.40 for that little heater. Now keep in mind, space heaters, when they're on high, a lot of them are 1,500 watts. So you'd be using like 50% more if you use a 1,500 watt heater. So it could be worse if your heater is more powerful. $130 per month, that's crazy. And this is why, yeah, heaters use up, 1,500 watts. You're using up most of the power for one circuit. And this is why every year we get emails about, hey, careful about, if you're going to use a space heater, don't don't use a microwave at the same time, and don't leave it on, or whatever, if you don't need it, and don't daisy chain your power strip. So if you plug into an outlet with a power strip that has 6 little outlet plugs on it, you can't plug another little power strip with another 6 plugs into that same one, because you could end up pulling more power than that circuit is supposed to. Remember when? Oh, this is moving on to the next part. Let's figure out the cost of to run a little light bulb. But do y'all remember when light bulbs used to be like 100 watts, but then they went to the curly fluorescent ones, and now they got LED ones that are kind of affordable, and or literally they now use less than 10% of the power that they used to. Yeah, it used to be those old incandescent ones. They're basically just a little heater that gives off some light too. Most of the energy goes to heat. So with these LED ones, most of the energy goes to light. So what if you left this on for a day? What would happen? You'd use that much energy, multiply by the cost of cost per energy, and that gives us 2 cents. So you would waste 2 cents if you left your LED light on for 24 hours. To get the cost to leave it on for a month, say every once in a while I'll go up to the attic or down to the crawl space and I'll be like, oh crap, we left the light on in here for like a month. So the cost for a month, let's just multiply this daily cost times 30, and we get about 60 cents of energy to run it for a whole month. There's people, sometimes we have a roommate or family member, whoever, who says, "Turn off the dang lights, you're wasting energy." And but it's really the lights anymore, if they're LEDs. That's just but pretty much insignificant contribution to your electric bill. Like it costs, you got a lot more energy going to use toward heating water and such. Every time you take a shower, it costs a lot to, at least, probably more than 2 cents to heat up your water or laundry or just even doing dishes.